Welcome to ClickMyProject.com. Let we discuss about the process enhancement of textural differences based on morphological component analysis. Let us see the abstract of the process enhancement of textural differences based on morphological component analysis. The enhancement of the texture images were more helpful in the identification of the visual characteristics of the images. The identification of the clear visual characteristics were helpful in the identification of the clear edges in the texture images. The images were decomposed into cartoon and texture components based on morphological component analysis. The textural characteristics of the images were calculated and analyzed with coarseness, contrast, directionality, and line likeliness. The identification of the textual characteristics were employed in high and low level of the images. The decomposed images were then combined in order to obtain the enhanced textural images. The input texture images were selected. The images were commonly resized to a particular size. The images were divided into cartoon and texture component. The decomposition of the images were done based on morphological component analysis. In morphological component analysis, the residual information is obtained in the first step. Wavelet transformation is applied to the obtained residual information. Threshold is applied to the transformed images in order to decompose the image. The same process is repeated for any one of the component as constant. The process is done repeatedly till the stopping condition is achieved in order to obtain the cartoon and the texture components. The images were manipulated and the textural characteristics of the images were calculated. The manipulated images were called as strong components and others were called as weak components. The characteristics measured were coarseness, contrast, directionality, and line likeliness, and they were measured for both strong and weak components. For strong coarseness, bilateral filter is employed, and for weak coarseness, wavelet thresholding is employed. For strong contrast, anisotropic shrink is employed, and for weak contrast, anisotropic diffusion is employed. For strong and weak directionality, SWT thresholding is employed. For strong and weak likeliness, gradient similarity based filtering is employed. The textural characteristics were well enhanced in the proposed method since the images were manipulated and the characteristics were studied. In the proposed system, complete image is enhanced compared to the existing methods for the enhancement of the images. Let me see the flow of the process. First, the input images were divided into texture and cartoon components. This decomposition of the input images is done based on morphological component analysis. In the morphological component analysis, at first the texture component and the cartoon component were assigned defaultly, and the initial texture component is kept constant, and the remaining component, that is the cartoon component, is enhanced, and after that the cartoon is kept constant and texture component is generated. So this process goes on iteratively till the stopping condition is achieved, and the resulting obtained texture and cartoon components were the decomposed input images. Then after that we measure the texture characteristics based on the coarseness, contrast, directionality, and line likeliness measurements. So while measuring this texture characteristics, we manipulate the images. So the manipulated images were called as the strong component. Manipulated the measurements obtained from the manipulated images were called as the strong components, and measurements obtained from the unmanipulated images is called as the weak components. So this process goes on. These components were all measured, and finally The texture component and the cartoon components were recombined in order to produce the enhanced image. Thus, the input image is divided into texture and component, and it is enhanced, resulting in the texture enhanced image, which is more enhanced compared to the input image. Let us see the running procedure of the process. If you want to run the code, select the file main.guy, which is present in the source code folder. The other files were the subfunctions used for this process. Right click main.guy and click on run file. You will get the process started. At first, select any one of the texture, image or normal images which is present in the dataset. So we can use any one of the textures or normal images here. So we select this texture image. So the process will get started. The input image is displayed here. After that, the next function is the decomposition of the image into uh, cartoon and the texture component, and this process is going on. This is the input image that we have selected, and this is the cartoon and the texture component that we have separated. This is the morphological component analysis cartoon component, and this is the morphological component analysis texture component. So this image is divided into cartoon and texture based on morphological component analysis, and in the next process the characteristics of the textures were studied. This is the strong and weak coarseness component. As we can see, this strong and weak coarseness components were obtained using separate processes for both of the either strong coarseness component is obtained from the manipulated image, and the weak coarseness component is obtained from the normal image. This is the strong contrast and the weak contrast components. So here we get the contrast informations from the images. The strong contrast component is obtained from the manipulated image, and the weak contrast is obtained from the normal image. This is the strong and the weak directionality component obtained. So this is the line likeliness component extracted for the strong and the weak component. So the strong and the weak coarseness components were manipulated, and it is displayed here. So this is the manipulated weak and strong contrast components obtained. And this is the strong and the weak directionality component, both were manipulated. This is the manipulated strong and the weak line likeliness process. This is the resulting texture enhanced image. So this is the input images that we have given, and this is the resulting texture enhanced images. This enhancement process is based on the morphological component analysis based decomposition of the images using into texture and the cartoon components, and this is the difference images obtained. This is the final performance measures that we have obtained. So the contrast, contrast, directionality and the line likeliness for the input image and the enhanced images were calculated, and the values were displayed here in the table and also in the form of a graphical manner. So thus we have enhanced the texture images based on the morphological component analysis and studied the texture characteristics of the images. Thank you.